Morning, today we are discussing about log diagram reduction techniques from control system. The control system, the log diagram technique is mainly used to reduce the number of complex networks in a single block. For that we go for log diagram reduction techniques. In the basic elements, the three basic elements are log diagram is summing point, blocks, and then branch point or node. Like that we can represent. The summing point is a one or two more inputs are connected to this summing point. Only one output is given. This was summing point, and the block is there given as a gain. Single block is used to represent the gain value of the corresponding network. And the branch point is one more point or one more element of this block diagram reduction. This branch point or node is used to get the output of the branch signal from one end to another end. Like this, we get this branch point or node. Here, the G of this is the block gain, and H of is the feedback gain, and this summing point is used to connect the feedback output to the given reference input. Here, R of S is the reference input, and Z of S is the final output of the block diagram. The H of S is the feedback signal given to this summing point. So here the feedback signal B of S. In this R of S and the feedback signal B of S is given the error signal E of S. So the final output is given as C of S in terms of error signal with respect to the G of S value block gain G of S. Okay. So this is the actual block diagram reduction technique. To perform a block diagram reduction technique method in this to solve the problem, we go for some set of rules are followed to reduce the block diagram reduction techniques. The 9 rules are followed. Before that, the advantages of block diagram technique is easier to representation of complex system, and the calculation of transfer function for the block diagram is also easier, and the analysis of the performance analysis of the control system is simplified by the determine the transfer function. The transfer function is mainly defined by the performance of the system. So the transfer function can easily identify or determine the help of block diagram reduction technique. That's why we go for the block diagram reduction techniques with the complex number of networks into a single network. And also facilitate the visualization of operation of the whole system by the flow of signals. That's why one of the main advantages. And disadvantages of the block diagram reduction techniques is it's difficult to determine the actual composition of individual elements in a system, and then representation of a system using block diagram is not a unique one. The main source of the signal flow cannot be represented definitely in the block diagram technique. These are the advantages and disadvantages of block diagram representation. So these are the rules followed for block diagram reduction technique. First rule, blocks in cascade. The two blocks are cascaded or series manner, that result will be equal block will be multi-block these two blocks will be. G, H is the two blocks are cascaded or series manner. The resultant block is G H. Like that we convert it into a single block. Two blocks are converted into a single block. Multi-block these two gain value G into H value. And the next one rule is that blocks in parallel. This is for series case. This is for parallel case. G1 and G2. Two blocks are in the series parallel condition with the one summing point which will be added by here. G1 plus or minus G2. Yes, the summing point is by either plus or minus is there. That's why you can connect the parallel combination of these two blocks can be equivalent block diagram is sum of these two values G1 plus or minus G2 value. This is a single block combination. The next one is the third one is that moving a summing point behind the block. If the summing point is moving from behind the block means from this point to this side we are moving the summing point. If this block is the summing point is moving from here to here means that is not moving the summing point behind the block. That's why you can go for this value. You have one more gain value. This gain value is multiplied with this block. The result is for moving the summing point behind the block. If the summing point is moving behind the block, in front of the block means this gain value is multiplied with this summing point. That is the rules for third one. And the fourth rule is moving the summing point ahead of the block. Now the summing point is moving in front of the block gain. That's why the gain value is 1 divided by G value. The gain value divided by the summing point. So 1 by G is added. Next one is the moving branch value. This is for these two for summing point moving ahead and before the branch point summing block. Here moving the branch point behind the block. The branch point or node is moved to the one more block. That is called branch point behind the block. If this branch point is moving behind the block means vice versa summing point upwards. So you get 1 by G varo. That's why G divided by 1 by G is becoming. The next one is that moving the branch point head of the block. That means branch point is moved from here to this point. The block is multiplied with this value. So G will be applied here. So that's why the both rules, summing point movement and the branch point moving, both are four rules are vice versa being changed. That's why one of the major rules. The next one is that eliminating the feedback rule. The feedback rule is that every block diagram has that one feedback is there. The feedback can be eliminated by this rules only. Either positive feedback or negative feedback in the feedback rule. So if it is a positive feedback means plus symbol there. If it is negative feedback means negative symbol is minus sign is there. So that's why this gain value will be for this feedback loop is G divided by 1 plus or minus G. If it is a positive feedback, 1 minus of G in the H value. If it is negative feedback means G divided by 1 plus of GH value. Like this, you can remove the feedback in the block diagram. This is one of the rules in the block diagram connection techniques. The next one is that interchanging the summing point. The summing points are interchanging from one place to another place. Like that, you can change. That is also one of the rules. If you are moving this sequential from one place to the corresponding sign will be changes to this here to that one and moving to the in front of the summing point. Like this, we are moving the summing point interchanging. So these are the some rules followed, set of rules followed for block diagram connection techniques.